Good morning, friends. Today topic grade unit number 4. So next one. What is redundancy? RAID. The RAID means abbreviation redundancy array inexpensive disk drive or redundancy array independent disk. What is the motivation of RAID? The computing speed double every 3 years and disk speed cannot keep up. The data needs higher MT means time between failure than any component in the system. IO performance and availability issues. So next one, rate to rescues. First one is based on performance. Second one is based on availability. The third one based on flexibility. Performance based on parallelism. Second one load balancing. Availability based on redundancy, mirroring or stripping with parity. And flexibility based on selectable performance or availability or cost. Next one. What is RAID technology? RAID technology means redundant array independent disk. That means disk array, the multiple drives and single host disk unit provide opportunity to increase the performance via parallelism and data availability in via data redundancy and cheap cost via commodity disk. Next one. We have first one. We have six RAID levels are available. First one is performance based disk stripping. The chunk size tunable for between versus throughput. That means between means bandwidth versus throughput trade-off. The large chunk is high throughput and IO per second, and small chunk high bandwidth megabyte per second. So driver 1, 2, 3, 4, 5. Next one. Next, availability redundancy is a mirroring the same data return both disk. For example, a single unit. This is a single unit is mirror with second one. So this is the same data return in both to the both disk. Stripping with parity. So the data stream or IO stream can be multiplexed across the multiple disks depending on bandwidth versus throughput. Parity data is also stored on the disk. So this is a stripping with parity. This is disk 1, disk 2, disk 3, disk 4, disk 5. This is add XOR parity for increase the availability of last one. Next one. Parity redundancy. Parity equal XOR of data from the every disk in the RAID unit. So data 0, 1, 1, 1, 1 stored. So data first input is 0 is stored here. The second input stored here, and third input is stored here, and fourth input is stored here, and last zeroth parity is stored here. So any single disk data can be recovered XORing the data of the surviving of disk. Next one. So RAID level. There are 6 levels are available. So many to choose from. Each offer unique trade-off based on performance, based on availability, based on cost. We offering levels 0, 1, 3, 5, 10. Next one. 0th level. So RAID 0th level disk stripping with no redundancy. There is no duplication data. So high performance, low availability, data stripped on multiple disks and multiple threads are accessed. So data stream or IO stream can be stripped across multiple disks based on bandwidth versus throughput. So disk 1, disk 2, disk 3, disk 4, disk 5. Next one. RAID 0 stripping. Chunk size tunable between chunk size tunable for bandwidth or throughput. There is no redundancy data. Next one. RAID 1 disk mirroring. The single disk performance, expensive availability and data 100% duplicate across both spindles. So single threads access. So same data returned to both disks, no segmenting. So here disk 1 and reply with mirroring with other disk. So this is a disk mirroring, so RAID level 1. Second, RAID 1 bar 0 steepened mirror, highest performance and most expensive unavailability, multi-thread access, so data stream or IO system can be steeped across multiple disks based on bandwidth and throughput. So single host unit, disk 1, disk 2, disk 3, disk 4, disk 5, steeped with and mirror with that one. Next one, the RAID 3 is a disk steeping with dedicated battery drive. So based on advantages means high bandwidth performance and cheap availability and sector kernel data steeping and single thread access. Data is accessing based on single thread access. So data stream is steeped across n-1 disk for high bandwidth. So this is a XR parity data. Disk 1, disk 2, disk 3, disk 3. The last one XR parity data. Next one, RAID 3 steeping. The chunk size equals single sector. Pure RAID 3 would be single byte. So all parity data on same spindle. So size drive 1, drive 2, drive 3, drive 4, drive 5. So last chunk 1, 0, 1, 2, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. These are fifth drive is a parity driver. Next one, RAID 5 disk steeping with a rotating parity driver based on high read performance, expensive write performance, cheap availability, tunable steep kernelitis, optimized for multiple thread access. IO stream is steeped across n-1 disk for high. That means IO means input per second for based on your throughput. This is a disk 1, disk 2, disk 3, disk 4 parity XR parity data. Next one, the RAID 5 steeping chunk size turn such that typical IO aligns on single disk. Parity rotation amongst disk to avoid write bottleneck. So before RAID is the parity bit is separately stored in the one disk, but now is a parity rotation amongst disk to avoid write bottleneck, so that you can mingle with your disk drivers. This is a RAID 5 steeping. Next one, so RAID 5 write operation. First read old data, old and new. So driver 1 and chunk 0 and write new data. So read old data here and write new data here and store in driver 1. This is a chunk 1. Next one, XR old and new data to create partial product here, means here. Next one, read old parity data here and 5 are old parity with partial product writing output result as a new parity here. So these two halves are stored in drivers 5. So parity bit. Next one, this is a write operation for RAID 5. Next, RAID level review. First 0 data steeping, no redundant data. That means there is no duplication. So based on high performance, low availability. RAID 1 mirroring, moderate performance, expensive, high availability. RAID 1.0 steeping and mirroring, high performance, expensive, high availability. RAID 3 steeping and single party check, high bandwidth performance, cheap availability. RAID 5 steeping and rotating parity disk, high throughput performance and cheap availability. Next one, summary. In this RAID concept whether is available in DBMS based on the summary of this RAID level. Increasing performance gap between CPU and IO, data availability of priority, and RAID meet the IO challenges based on performance via parallelism and data availability via redundancy and flexibility via multiple RAID levels. Each offer unique performance, availability, cost trade-off. Next one.